Learning topic, review of exponents, and we're going to go over quite a few definitions for this particular topic. So first, let's let A represent a real number and let N represent an integer. Therefore, for A raised to the nth power, A is the base and N is the exponent. But now we need to define what an exponent is. So an exponent is used to indicate how many times the base is used as a factor. So we need to also understand what a factor is. So factors are connected by multiplication. So if you think about the number 6, 6 has factors of 2 and 3 because 2 times 3 is equal to 6. So remember, factors are connected by multiplication. Also a reminder of definition of an integer. We talked about this before. So a set of numbers, remember the ... means it goes on forever. And so this is -1, 0, 1, 2, 3, and it goes on forever in the positive direction as well. And then the last definition I want us to talk about is a coefficient. And a coefficient is a numerical or constant quantity placed before the variable in an algebraic expression. And we're going to see coefficients being used in this particular set of notes in a little while. So let's get into our exponential rules, and for each rule you're going to have at least one question. So there'll be a lot of stopping and starting with this particular video for your homework assignment. So let A and B represent real numbers, and we're going to let M and N represent integers. So that means A and B can be irrational numbers, they can be decimals, they can be whole numbers, etc. But we're restricting and letting M and N, which are going to be our exponents, they're going to be restricted to be just integers. So our first rule is the product rule. And so the product rule states, like bases multiplied, we're going to add our exponents. So our exponents are M and N. So A raised to the mth power times A raised to the nth power is going to give us A raised to the M plus N. And so you will have a question right here, question number 1. And so question number 1, I also want you to take this a step farther and make sure that you simplify this. So this can go a little bit farther, and you're hopefully going to see why when you explore this. As always, if you have questions, you make sure you let me know. The next rule is the quotient rule, which is very similar to the product rule. So I want you to hopefully make the connections here. So like bases multiplied, we add the exponents. So like bases divided, we're going to subtract our exponents. So this is M minus N. Now a little bit of a note I want to make here. M minus N, that could be a positive number. It could be equal to 0, which is actually our next rule. Or it could be negative. And if it's negative, we cannot be done. It's not proper mathematically. So we're going to have to clean that up. So we're going to see, okay, what do I do then if the exponent becomes negative? We'll talk about that. And so we have a question here, question number 2. I'd like you to look at y to the 9th divided by y to the 7th and simplify this using your exponential rule. Next question, okay, what happens if my exponent is 0? Well, this is always equal to 1. And the reason for that, if you think about y to the 9th over y to the 9th, Well, anything divided by itself besides 0 is equal to 1. Well, what if we went back to this rule right there? We would subtract our exponents, and y to the 9th minus 9 is equal to y to the 0, and we're back to that equaling 1. Now you have two questions here, but please notice that these are very different. This is 2x housed in parentheses, so everything is being raised to the 0, versus the second question here. We have a coefficient of 2 times x to the 0. So make sure that you focus on the differences between 3a and 3b. Our next rule is the power rule. Now another way to state this rule is if you have a power raised to a power. So a to the mth raised to the nth power. We're going to multiply those exponents. So make sure you take a look at that rule and apply it to the next question. Our next one is the power of a product. So notice again, inside we have two things that are connected to each other by multiplication. So a, b is implied as a times b, housed in parentheses. So the whole thing is being raised to the mth power. So this means we can take a and raise it to the mth power, as well as b and raise it to the mth power. So we are essentially able to distribute that exponent to each of the pieces in the base. Now, one of the things that's going to pop up in this class, what if you had something like this? This is not equal to a to the mth plus b to the mth. And we're going to see why that is true later on in this course. And you might know it already, but make sure you know you cannot distribute an exponent over terms. Terms are connected by addition or subtraction, so make sure that you do not do that. And so make sure you tackle question number 5 in your video. Rule number 6 is very similar to rule number 5, and so the only difference here is instead of a and b being connected by multiplication, they're being separated by division. So we can use the same rule here. This is a to the mth divided by b to the mth. And question number 7 is a combination of question number 5 and 6. Everything is connected by multiplication or division. So we can take a, raise it to the mth power, x to the m, and then divided by b to the m and y to the m. So everything can be raised to that power. And our next one is looking at negative exponent. And we do need to make sure that a cannot be 0. Remember, if your denominator is 0, that is undefined. So we're not going to be able to let a be 0 here. So if we have a negative exponent, and that is in the denominator, then we're going to move the base to the numerator. So 1 over a to the negative m becomes a to the mth power. And notice we no longer have an explicitly stated denominator anymore, and a is now moved into the numerator. And so I want you to tackle this with the next question. But what happens if your negative exponent is attached to the base that is already in the numerator. So we're going to move that base from the numerator to the denominator. So a to the negative m is equivalent to 1 over a to the positive m. And our last rule is if we have a fraction raised to a negative exponent. There's two ways to handle this. We could take a and raise it to the negative m, but that means b also has to be raised to the negative m. Now this is very similar to the question that you were asked here. So if you got stuck on this one, you might be able to think about how to tackle this in the future. A to the negative m, that's not okay because we have a negative exponent. So I'm going to take that base and I'm going to move it to the denominator to make the exponent positive. B also has a negative exponent, so I'm going to move that to the numerator. Now, another way we could have handled this is saying I want to make that exponent positive. So I'm going to make it go from negative m to positive m by flipping or reciprocating the base. So that's b over a. And notice I can now apply our power rule. So b to the m over a to the m. And that's our last question.